Thank you for coming to my talk. I'm going to introduce UARS, minimal and secure rewrite of update engine in Flatcar in Rust. So I'm going to introduce myself. I'm one of the maintainers of Flatcar Container Linux and have been working as a software engineer in user space Linux and cloud native ecosystem. However, I'm actually a newcomer in the Rust world, so I'm in the middle of learning Rust and ecosystem. First of all, Flatcar Container Linux is container-optimized Linux distribution. It is based on Gen 2 as well as Core OS Container Linux. It has a little bit of a forking history of that, and basically it has three major aspect features: minimal image size and secure and immutable file system, and automatic rolling updates. So, for example, secure and immutable file system, though this one is very critical for our image-based OS, as you have already seen in the last years. And also the third one, automatic rolling updates, are also very important for controlling many nodes at the same time, so that users do not have to care about manual updates and so on. This project has been CNCF incubator project since last year, October. And yeah, feel free to look into the blog post or our conference talks given by other Flatcar folks. And I'm going to today focus on one part of Flatcar, which is update engine. This is a crucial part of a rolling update mechanism of Flatcar. So it is basically to allow you to update OS version to the newest and very smoothly. For example, if you want to do an OS update in a traditional distro, then you need to first download an image and verify and apply that image to the root file system and reboot and so on. Those all steps are done automatically in Flatcar. So that's what update engine is doing. So not only main OS images, but also additional OEMs for other possible all cloud providers, Azure and AWS and so on. Also, this update engine has a pretty long history. So it has been originally written in C++, so 19% of code is still in C++. And when Core OS Container Linux forked that project, and they added some bash code into that, so some parts are written in bash. So Chromium OS has originally implemented this update engine around 2010, and after that, Core OS Container Linux forked that project again, and they wrote some and added some code into that, and that project also went to end of life, and that's when Flatcar took over the project. That's 2018. So upside of this long history is that we are able to have reliable and update mechanism tested for many years, stable, working well. Downside of that is full of legacy code inherited from predecessors and untouched for years. And even if some maintainers would like to add some features or add some new standard for OMA protocol, for example, then it feels like a little scary to touch, and it is time to clean up. That's the current status, and I'm going to briefly go over the update engine subparts. So first two these are actually familiar to users. Those are user-facing ones. The first one is client, and the second one is server daemon. Oops, sorry. The first one is a client tool that controls the daemon, and user types the update engine client and /update and so on. And the second one is actually the crucial part of update engine daemon that listens to the request from the client and relaying the request to the remote Nebraska server. Nebraska is also another open source project, and I'll explain later. The third one is actually not user-facing tool, but it is a very important tool, data generator, that generates binary diff between two different versions of images, and it's integrated into the CI and build image step of or Flatcar image build process. The last one, Flatcar post-ins, it was not written originally in Chromium OS. However, after forking from the course container Linux, then those folks added the script in Bash to take care of post-install action in Omaha response. So we felt that this is the time to rewrite update engine in Rust. However, we need to be as minimal as possible, and also follow the standard for security-oriented programming practice at the time. So that's why we chose Rust as a programming language for that, and called the project name UARS. So that started in late 2022, and it has to clean up legacy code in update engine, and it has to keep only the minimal and crucial part of update engine. So, for example, the parsing Omaha protocol from scratch, as well as pure RSA library instead of relying on OpenSSL, so that we don't have to rely on the bindings around OpenSSL and so on. Also, it aims to be pluggable for integration with other OS update mechanisms, such as SystemDSS update. I'm going to introduce Omaha protocol used in Flatcar. Omaha protocol is a communication protocol for rolling out updates. So it is basically a request response based on XML data. And Google originally created this protocol, so you can go to this link and read the specs and so on. However, it is not so actively right now. So, Omaha protocol's client side is updated engine, which resides in Flatcar OS images, and it runs as a daemon that automatically checks for new versions or updates to the new OS version and so on. And the other side is server side, which is a Nebraska server that holds all the binary artifacts served by public update instances. So, for example, the public.update.flatcarlinux.net, that is the default production server for Nebraska. Yeah, Nebraska is also an open source project under the Flatcar org, GitHub org. And another interesting thing about the Omaha protocol is that you define what to exchange and how, what kind of type of each field is. Such things are defined in protobuf file, and source files are generated from that. So code generation takes place, and you can, for example, generate that into pb.csv or pb.h file or .rs file in case of Rust. So you never touch the existing the destination file, because after code generation, they'll be overwritten. I will show you an example of Omaha protocol exchange. So for first of all, request. There is just a simple XML data. So update engine and current version, and track. Track means specific channel of Flatcar. So for example, LTS, stable, and beta, and alpha. Alpha means a bleeding edge channel. Also, this is the OEM is QMO, or board is AMD64, and so on. Such kind. This is just straightforward. More interesting one is the response. So this response is given back to the update engine. So the URL for the artifacts update payloads are given here, and a manifest version and Flatcar production update.gzip file. That is the main basic update payload file. Is hash function and size, so those things are defined here. At the same time, all the possible OEM files are generated in the same packages list. So I listed only a few of them. It has many of them actually. So it has also, each of line has hash and size and so on. So after update engine gets the list, then of course then only corresponding specific OEM would be applied, downloaded and applied, and so on. So if you download an update payload, so typically 300 megabytes of file. In case of OEMs, less than 100 bytes, and so on. But it has a structure like that. It has, first of all, header, and after that, manifest, data blobs, and signatures. Header and signature, those are actually trivial. However, manifest and data blobs, those are not so trivial. So first of all, I will talk about the header. That begins with the magic stream CRAU. That is a predefined one. And file format version, that's trivial. However, manifest size means the following manifest fields size. So the following manifest field can vary in size. That its size is defined in the previous header. Manifest file also has a lot of data definition, and to be able to locate at which location the data chunks are read or written. So partition operations, that is a list of multiple partitions, and it has arbitrary lengths of a list of many chunks of data. It has a block size and signature offset and a new partition info and so on. So if you want to read actual data from that, then you need to actually iterate into the manifest partition operation and go into each entry of partition operation and locate the data offset and destination extent times block size and so on. So you need to get into that. It sounds a little tricky, however, it is already did and implemented both in update engine and UERS. Also, signature, that is also at the end of the update payload. And actually, where is that signature located? That is also defined in the previous manifest. Here, signature and offset, signature size. Suppose SHA-1 and SHA-256 algorithms. So current state of UERS, it is actually still a proof of concept. However, building blocks are already there. So we have a library for parsing Omaha messages that is called Omaha. If you clone UERS repo, then there is a subdirectory in Omaha. And also there is a library for parsing update payloads and verifying signatures. Those are located under update format CRIU. These two libraries are pulled in by another standalone binary, which is download sysext. That is to download sysext with images from the remote server and parse Omaha response and verify signatures. So of course that relies on the local libraries, Omaha and update CRIU. This tool, download sysext, is already included in Flatcar Alpha 3850. That is released in January 2024. So basically every version since that, including stable version right now, all versions have it already. However, it just invokes that script inside the Flatcar posting script, and it so it works well. I'm going to give a short demo. So if you have a Git repo, then you compile that into the download sysext file. You can run it with the help option, and there is a pubkey file and payload URL file, URL options. You can specify. Now you can do it like that. You can specify payload URL, actual download file, OEM azure.gzip, and also to specify output directory and pubkey file. In this case, the official pubkey file should be used because this is just a production file. Downloading that file and writing into the .unverified file to avoid naming conflict and so on, and verify the signature. And if succeeded, and you moved into the actual file, OEM azure.gzip. That's actually it. And the second one is that there is a QMO image file for CI. Actually, in that case, we need to specify developer pubkey to verify the signature. That has already been done and successfully done. And already downloaded under unverified file, and also did renamed into the actual target. That's it for my demo. I'm going to introduce practical issues regarding the current UERS. So 2023, there was a Marvin attack discovered about the cryptography attack, and some software were updated to fix that issue. However, in case of Rust RSA create, it is not so easy. So it has not been fixed so far until now, and we already tried to get rid of the dependency on the RSA crate. However, it did not work well because of the heavy dependency. And meanwhile, actually, RSA project is trying to get into the final release 0.10 to fix that issue finally. And so we are working on that. Hopefully, it will be finished soon. Also, Omaha crate was originally implemented by the original author, William, and he left, and there has been room for improvement for 4 years. However, recently some external contributor, James Parkey, did huge effort for improvement and refactoring of Omaha crate. So I'm really impressed. So I want to really appreciate. There is a possible future work. So, for example, the right now the UERS is just a proof of concept, including download CSX and command line tool. However, actually, ideally, this should be implemented as a client-server architecture. That is already done in Update Engine. And in case of Update Engine, just the legacy dbus communication, however, that dbus could be also done in UERS. So that's the option number 1, using the ZBus library. Another option would be using varlink instead of dbus. So there is a nice talk given by Zishan today, Z-Link. That might be an option, so we need to look into that. Yes, that is still at research level, and yeah, feel free to comment or question. Another work is to create a state machine model. That's already done in the original Update Engine, and basically Update Engine has many states, more than 10 different states. For example, idle, update available, downloading. Those states should be transitioned in, one after another. However, if that gets messed up, for example, if you go from update reboot needed to downloading directly, then that's not good. That's just not ideal. So we should have a clear state machine model between those transitions. Yeah, we have GitHub repo and metrics chat. So feel free to look into the repo and join. Also, I want to thank to community contributors. First of all, William, who is the original author. However, he left Flatcar team right now. Anyway, I'm going to give huge credit. And Kai, yeah, he is still active. So huge thanks to them. And other folks also, including. That's it for my talk, and thank you. And any question?